Good day, and welcome to CFE Media's Virtual Training Week. For this session on the organizational implications of digital transformation and Industry 4.0, we'll be joined by Kevin Prouty, IDC Group VP of Manufacturing Insights. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. A certificate of completion will be available for each participant to download upon successful completion of a test at the end of the presentation. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RECEP. Everyone talks about digital transformation and the application of technology to enable new or modified business processes, but few talk about the organizational implications. This is especially true in operations as digital transformation comes wrapped up in Industry 4.0. As digital transformation accelerates, the key transformation is around decision-making and the framework needed to make faster and more effective decisions. That decision-making framework has traditionally been the responsibility of a middle management with a very manual and report-centric process. But the formation of digital engineering groups is becoming the standard approach to digitalize that decision-making process. This session focuses on developing a resilient operational decision-making framework. Learn how to build a digital engineering organization to support that architecture. Transform your middle management organization to meet the needs for resilient decision-making. You see before you some of the learning objectives for today's session. You see before you some tips to help you get the most from today's session. Attendees are eligible for one PDH credit for this event airing on October 18, 2021 and categorized within the technical health and safety categories, including core technical category for RECEP. This event is a live educational session presented on October 18, 2021 and on demand thereafter. I'd now like to introduce today's presenter. Kevin Prouty is Group Vice President for IDC Energy and Manufacturing Insights. He is responsible for managing a group of analysts that provide research-based advisory and consulting services that enable energy executives in oil and gas and utilities to maximize the business value of their investments and minimize technology risk through good planning. Kevin's research specialties are in utilities, manufacturing, enterprise applications, and product innovation research. Before joining IDC, Kevin was Senior Vice President of Research at Aberdeen Group. He also spent over 5 years as Senior Director of Manufacturing and Energy Solutions at Motorola and was the resident expert on technology's role in continuous improvement. Prior to Motorola, he was Research Director for Manufacturing and Automotive at AMR Research and Gartner, where he spent a cumulative 6 years. Leading up to his research role, Kevin spent over 15 years as both a user and systems integrator of operations software. 12 of those years was as a plant manager and project manager at a global manufacturer, managing a large workforce and business that produced tooling for automotive and industrial companies. Kevin, welcome to today's virtual training session, and please go ahead.
All right, thank you very much, Kevin. That sounds weird saying Kevin again, but anyway, so as stated, I'm Kevin Prouty. I'm the Group Vice President for Manufacturing Insights at IDC. I have a very strong background in manufacturing. I've worked in multiple positions, engineer, plant manager, I've run IT, I've done a bunch of different stuff. So I bring that perspective to being an analyst and looking at, what's happening in the digitization of manufacturing, and specifically around, how are companies organizing around that digitization, that Industry 4.0 stuff that's happening. So I want to start off by just kind of, laying the groundwork for digitization and why people are digitizing. I'm not going to belabor this because I think everyone kind of knows already. But the short of it is these are a couple indexes we track around digitization. We have a methodology for looking at how digital a company is, and we've been tracking it for 5 or 6 years now. And what you can see here is you can see companies that have digitized, manufacturing companies that have digitized, outperform both on the revenue side and the profit side by a fairly wide margin. Even during the pandemic, we saw this, that even though all companies across the board took somewhat of a hit, it was much less impactful on companies that were already digitized, because they tended to be a lot more resilient to large changes happening in the market. Another piece I want to bring into this digitization discussion is sustainability. A lot of discussion around sustainability, whether you're looking at sustainability as just kind of organizing stuff you've already been doing, or it's a new tack for your company. We also found through this index that companies that were more digital tended to also be much more sustainable. And that sustainability was recognized by stockholders, shareholders, the financial community, as well as other types of investors. So the short of it is, digitization isn't just being done for the sake of digitization, and companies have to be able to work around that digitization. They have to organize themselves around how that digitization is changing not only their market, but their actual operation. Just a few quotes. I'm not going to belabor these. You can look at them at your leisure. But I think the short of these conversations are innovations happening, and it is having an impact on operations and IT, and how IT supports operations. And this is where that fundamental core is for how companies need to organize for Industry 4.0 and digitization. I mean, some of the points here, I have this nice little story about a CIO was being frustrated by the number of Raspberry Pis showing up that engineers were putting into operations to collect data and actually to make some fairly insightful decisions. And they brought it up to the board about how do we manage this? And the board of directors of this very large company said to the CIO, "You cannot hold those innovations back. We do not want you to do anything that really puts a damper on those engineers trying to innovate and make our company better and make our product better. You have to find a way to build a framework for those individuals and those or parts of the organization that are trying to innovate with technology." This realization came to the CIO that, he's living in a new digital world. This is not the old world of IT telling people how to manage technology. Technology is being driven up into IT. So they really needed to take a fundamental look at their organization. And I'll talk about that in a minute. The other thing that's happening, even outside that innovation, and maybe somewhat related to it, is just the massive increase in how much data is being generated and consumed inside manufacturing organizations. If you look at, this is from a report we wrote a couple of years ago, look at 2019, on a typical industrial operation, you have about a terabyte a day of data being generated if you add up the 0.14 and the 0.94. Now, what you can see here is it's about a terabyte that's generated and not used, and about 10% of that, a little over 10% of that, is actually being consumed. And when I say being consumed, that means someone's using it for some advanced analytics. Maybe they're using it with AI and machine learning, or maybe they're just using it in reports somewhere. But the shocking thing is here, it's just about 10 to 15% of the data that a company generates in its operation is actually being used to make that operation better. And now if you go all the way up to 2025, you can see the amount of data being generated more than triples. In some industries we've seen it's up to 5 to 10x what it is in 2019. But the most interesting part is, look at how much is being consumed. You've got a terabyte of that 3 to 3.5 terabytes of data being generated actually being consumed. So it's going from around 10% to almost a third. So that's a pretty significant increase. And this is, again, just reflecting on the digitization of organizations and how they need to build their organization around that digitization, because otherwise you just can't, you're not gonna be able to follow the market and being able to consume that data and use it to optimize your business. So we built this continuum. This is only a high level view of it, but we call it the Industry 4.0 continuum. And it's if you think back to the data I just talked about and the innovation that's going on, this is a continuum we use for companies and how they move through the roadmap to Industry 4.0. First, there's the digitization piece, which is ongoing. It means I call it shining a digital flashlight into areas of your operation that you probably couldn't get to before because the cost of the digitized or connected sensors and machines is coming down. The next big part of the continuum is monitor. Once you've digitized everything, what do you do with it? So you start monitoring your operation and your assets. Then this is where the intelligence comes in, and that's the diagnose part. So you've been monitoring it, but so what? What are you doing with that data? What are you actually consuming it or just storing it? The diagnose piece means you're actually looking at that data either through subject matter experts, or maybe you got a little AI looking at things like pattern recognition, and you're starting to be able to diagnose the issues and maybe even start to predict issues before they come about. Then there's the control piece. Once you start predicting those things, what do you do about it? Can you actually control what's going on? A good example, I used to have an accumulator room in my old plant that had about 40 pumps in it. And no doubt when the market got busy and we were at the high end of the market, someone would come to me, we got to shut the accumulator room down. We got 4 or 5 pumps that are, they're going to fail in a month if we don't shut them down. So the decision by the plant manager was, gee, do I shut it down and miss the key part of the market? Or do I just say, you know what? I'm going to eat the $5,000 it's going to cost me because I might burn out those pumps. That type of control, as you're starting to diagnose issues, can you go back and make decisions? And this is where the decision making gets important. Then there's the next step of the decision making. That's the autonomous piece. That's the ability to turn over some of those decisions to things like AI. You build all that knowledge through machine learning, through your subject matter experts. Can you apply that in a decision-making framework that allows you to basically, as the person in charge, skip some of those decisions and let the AI make those decisions for you? Now, of course, we're not going to pull humans out of the space completely, but we're trying to build a decision-making framework that supports that human decision-making. So that's how we look at that digital transformation or Industry 4.0 continuum. And again, the organization needs to be built to support that. Now, I just want to talk about, before I jump into the organizational piece, again, just another aspect of Industry 4.0. We did a very large survey of a number of manufacturers, over 1,000 manufacturing companies, basically asked them, if you don't invest in Industry 4.0, what do you think the negative impact is going to be on your performance? We asked them to list the KPIs and we asked them to estimate the negative impact. These, if you look at these KPIs that are on the screen, these are your pretty typical KPIs in manufacturing. Downtime, productivity, energy costs, scrap, go all the way through this. They're all there. And every single manufacturing executive we talked to said they're all negatively impacted by not investing and moving forward with Industry 4.0. If they just keep going the way they are, maybe they're lean, maybe they're not, maybe they're already, fairly lean from a standpoint of manual processes. But that next step is that automation of that decision making. It's that Industry 4.0 roadmap. But this is what they said would be the impact in not investing in it. So you can stay nice and even, but your industry is going to move forward ahead of you. So you always need to be thinking about these KPIs and the impact of not doing something, because that's usually the easy decision for people, is to not do something. So we now know a little bit of the cost of not actually making a decision. So one of the organizational impacts that I think is most profound around Industry 4.0 and digitized manufacturing, it's something I think we generally call remote operations. And there's many different aspects of it. But what we see with remote operations is it's not pulling everyone out of the plant. It's basically trying to take all your subject matter experts that are scattered around to all of your plants and bringing them to either a central location or a virtually centralized location. So everyone in the organization has access to it. And the organizational structure around that is, I call it like an IT help desk. You've got your more junior people who are going to, well, actually, your first level is going to be some sort of automated decision making. But the next level of that IT like help desk or IT help desk like operation is you got a junior level engineer who's able to handle some of those calls. I have one client that I think is really interesting in how they do this. One of their key technical challenges in manufacturing are drives, high speed, high accuracy drives. And every single one of their plants and all their plant managers I talk about the lack of knowledge in those plants to be able to quickly diagnose and fix problems with those drives. So what they did is they created this remote center where all their subject matter experts on drives were located. And in fact, only some of them moved into a central location. Some of them stayed in their plants, but they became virtual remote experts. And they were able to connect all the drives in the operation into a dashboard that was part of this, what I would call collaborative manufacturing help desk. So when one particular plant was having a problem with some drives that were slowing down its process or causing bad product, that central location or that remote operations center could start out by supporting them, and eventually they can start to predict the problems. So you start, and just like I said, you start with a level 1 engineer who can support some basic stuff. You get to a level 2 engineer who's probably a 20-year veteran, someone like that, who's seen a lot, would typically go out and put their hand on a drive and say, yeah, I can feel the vibration. They're looking and they're seeing the new higher current draw, so they know there's a bearing going bad. Now, of course, there's also a third level above that, and that's someone who's actually going to pick up a suitcase and go out to a plant and look at the problem. But the key point here is to bring all of your subject matter experts into a virtual center for remote support and remote expert help, which eventually translates into potentially complete remote operations. And I think just to kind of give some validity to it, I'm going to talk about a couple things here. Today, we see 7% of asset-intensive companies actually establishing those centers or have established, and we see another 25% actually starting to stand up those centers. And I think that's a pretty rapid uptake, and we're seeing the kind of the pandemic and the post-pandemic world really starting to accelerate that. In fact, here are some companies that we see doing it today. Companies like Linde, big gas company. They've been doing this for literally decades, and they're just at the point now where one engineer supports 10 plants, whereas they used to have a staff of engineers in every plant. Another company, Saint-Gobain, using machine metrics, a small software company with some hardware capabilities, basically sitting on CNC lathes. And they've got subject matter experts sitting back in a remote location, monitoring all those lathes and grinders. And then Georgia Pacific, it's been fairly public about this. They've standardized on OSI Soft Pi and AWS as a data foundation, but they're building this collaborative manufacturing center to get as many remote experts available to all their plants as they can get. So what does the organization look like? When we start talking about it, you might think, oh, we'll just throw a bunch of engineers into a remote operations center and let them go at it. But there's some key things you got to understand here. There's some changes on the market side, and there's also changes on the technology and the IT side that you have to really consider. A typical, this graphic you see in front of you, we call it future of operations and digital engineering. Future of operations is being able to tie your operation more tightly to your market or become a very market-driven operation. Doesn't mean you throw things like lean and continuous improvement away. They're still a critical tool. But the operation needs to be able to be more tightly linked to the market. Part of that is something we call resilient decision making, and that's a very, very rapid and effective decision making process and infrastructure. If you think about how decisions are traditionally made, I know back when I was an engineer and even a plant manager, I would get information on what was going on in my plant that might be over a week old. And so it would take me another week to make a decision. By the time it actually got to the point where the action was going to be executed, it could be a month later. And by that time, that information is completely stale. I may actually be making decisions that are making things worse. When you sit in a plant, if you work in a plant and all of a sudden you see this decision come down from senior management, and you're like, what were these guys thinking? You know what they were thinking? They were thinking about this 3 months ago. So the whole point of this digital engineering capability is to create this very rapid and more effective decision making. And that digital engineering group, if you look up here on the chart, they sit between operations and the executive decision making. And on the other side is information technology. They're handling financial reporting, customer data, stuff like that. Digital engineering is sitting there handling all the data, the AI, the robotics, and the data coming out of your robots, or even robotic process automation. But it's all about creating a data infrastructure where this resilient decision-making process can sit on. So I think, that's just something to keep in mind. One of the cores of the concept of digital engineering is, who are the digital engineers? Who goes into that organization? And I think a key part of this is going to be around, and what we're seeing today, you're going to have subject matter experts, mostly engineers, and maybe very seasoned supervisors and managers and even operators. And you're going to have people from IT, because what IT has to do is they have to maintain the infrastructure, because there's so much data coming in and out. And it may not just be between operations and management. It may be suppliers. It may be OEMs who are building your equipment for you. It may even be customers. But there's data flowing into this digital engineering organization, and they're responsible for making sure the data is organized, ingested, contextualized, whatever you want to call it. They need to get it ready so that decisions can be made. That data needs to be turned into information for decision making. Now, it's not all going to happen at once. We have a number of our clients that have these digital engineering organizations, and they're in various states of maturity. In some cases, they're what we call coordinated. IT and the subject matter experts and operations are separate, but they work under a similar mandate. They're managing cybersecurity. They're managing all the models being built around AI and advanced analytics. But there's still two separate parts of the organization that are just, I would call it, not tightly linked, loosely linked. Then there's collaborative. And this is where we see most of our clients right now. They've actually formed a real digital engineering organization. It reports into operations. They've taken people from IT, they've taken subject matter experts, and they've taken what I would call true digital engineers, people that can do both, and they put them into one organization, reports into operations, still has a dotted line to IT, where IT is making sure, or I should say digital engineering is making sure that the company and this organization, the operations, is following IT policy on security, data handling, data management, data governance, and networking and connectivity. And so that's why you have to have IT involved, because IT has to be able to handle all that stuff. And they have to support the digital engineering group, who is in turn supporting operations. Now, the next step is kind of the ultimate goal, is converge, a completely converged IT and ops group called digital engineering. You don't have separate IT people. You don't have separate subject matter experts. They're kind of the same person. And even in that organization, you might have OEMs and suppliers and consultants as part of that organization. So you've got a lot of third-party people in there as well. One of the things I want to point out before I get too deep into this organizational change is, what's the role of middle management today in a manufacturing organization? I think the key part of when you look at what the role of a middle manager is, they take information or data from an operation, they bring it into themselves or into their part of the organization. They manipulate it, massage it, pass it on. They might make a few local decisions, but pass on the information, and it keeps going up the chain. Couple problems with that particular, especially in today's environment and the velocity of a lot of our markets, is it takes time to pull that information in. It takes time to manipulate it, put it into a report, and move it up the chain. But there's something key that happens there too, and that's called personal bias. Middle managers will put their personal bias. They'll think, oh, this piece of information isn't important, or I'm going to reinterpret this piece of information because I know the context around it. And that happens all the way up the chain, to the point where by the time the information gets up to a senior manager to make a critical decision, you probably don't even recognize the information anymore. It's probably out of date. It's had a lot of personal bias applied to it. I mean, that middle management job is really to ingest information and interpret it and get it up to senior management for decisions. And that's a slow, in some cases painful process. It also takes a lot of people. It's a lot of people, not just the middle managers themselves, but there's usually a staff of business analysts who are going out and collecting all that information and bringing it together. Now, what we see in the future, we see this resilient decision-making framework that really, the structure of it replaces middle management. And we're not firing all the middle managers. What's going to happen is those middle managers, they're really, really good subject matter experts typically. They're going to move into this digital engineering role. They're going to become some of the subject matter experts. But the whole point is to increase the speed of moving the data around to eliminate as much of the personal bias as possible, basically, as I said before, to create a faster, more effective decision-making process. So when you're looking at your manufacturing organization, you need to be thinking about this digital engineering organization and where does it fit? And how do you move middle managers from being, people who are slowly collecting information, applying personal bias, basically they're just building reports. You need to move them into this digital engineering role. It doesn't mean they stop being, maybe frontline supervisors, but you got to change how the information flows, and you need to build this framework around it. This kind of takes us into a topic a lot of people talk about right now when they talk about Industry 4.0 and digital manufacturing, and that's IT/OT convergence. And IT/OT convergence to me is pretty straightforward. There is an IT structure around the business systems. There is an OT structure, which is focused heavily on just the physical process of making stuff. The IT/OT convergence piece is really driven by this digital engineering organization. It's about making sure all the policies and guidelines coming down from IT are applied to operations in the context of operations. IT/OT and digital engineering, they're not in charge of PLCs. They're not in charge of data historians. They might have a little bit of say on the data historians. They're not in charge of the control systems down in the plant. What they're in charge of is making sure all the data is moving back and forth. So I think it's that IT/OT convergence piece that you hear a lot about. This is where it fits. So one of the things we did working with one of our clients, we created what we called an Industry 4.0 reference architecture. This is a very high level architecture. You're not going to go out and issue purchase orders on this stuff. But what we're trying to show is the 5 or 6 different layers you need to be concerned about and the types of technology in each one of those. At the very bottom, so if you look, there's a dotted line going across, that's the site level. So on site, at a plant, at a warehouse, whatever it is, you've got devices and assets, robots, sensors, all that stuff. And you've got production and process software or systems like SCADA systems, MES, quality management systems, safety systems, all that stuff. That's on site. And they're connected either amongst themselves or as they start to bleed up into the enterprise, they're connected through just simple analog to digital converters, maybe legacy serial connections, field bus connections, Bluetooth. You may have OPC converter in there. Nowadays, you see a lot of things called edge gateways and edge servers that are basically able to take almost any signal coming out of operation and digitize it and get it up into the cloud. And then that brings us offsite. Although there's a little bit of connectivity on site, but when you go offsite, you're going offsite through Wi-Fi, 5G, LTE, any type of Ethernet. So that's the big connection. That's connection with a capital C. And it's also where security is really starting to play or has been and continues to play a prominent role, because that's getting information up into, maybe it's an IoT system, maybe it goes straight into the cloud and there's some long-term analytics that gets done. And then there's the decision-making piece, above that, artificial intelligence, machine learning, model management. There may be a lot of manual decision-making that happens, but these are the major layers of that reference architecture for Industry 4.0. So we decided to take that reference architecture and assign parts of the organization we think are most responsible for maintaining it and making sure that it operates efficiently. Starting at the bottom, obviously, operations is responsible for all the stuff going on in the plants. Digital engineering and operations are both responsible for that site local connectivity. You could say operations is solely responsible, but digital engineering needs to be involved because they need to know how all this is going to connect up to the decision-making systems. Then when you get into connectivity, again, digital engineering and IT, mostly digital engineering and how it connects to the plant, but IT is going to have to set the frameworks you're working with. They're going to have to set the governance around connectivity and the security around connectivity. Then above that, you have digital engineering taking in all that information. I call it operational data streaming. And that is all this data that's flowing out of the plant has to go somewhere and it has to be ingested, contextualized, and basically just connected or accessed. There's a big data governance model that goes around this and how all this information is dovetailed into the enterprise and transaction information. Digital engineering, that's one of their core roles. Then above that, you have IT, things like analysis and visualization. And then there's enterprise and enterprise operations. And this is where you start to get into things like, decision-making frameworks, building out an AI-based decision-making framework that takes advantage of all that data that is being streamed out of operations and applying it to the rest of the enterprise. And on top of all this, you build your use cases, because one of the things we found is no one's going to buy that decision-making framework on its own. It's very hard to justify. Where it gets justified is if you have something like an asset management system you need to implement, or you think you can do predictive maintenance better, then you start to build out this reference architecture on the back of asset management, on the back of your predictive maintenance system. And then you can start applying other use cases. Those other use cases will come in and basically be able to use that reference architecture you built at, I'm not going to say no charge. There will be some charge. It'll cost something, but at a much reduced cost than that first use case. So that first use case you bring in has to be a very value-driven use case. There has to be a lot of value driven by. You get into process industries, very asset intensive. That tends to be where you can build your reference architecture around, because there's an immense amount of value in reducing downtime. On the discrete side, tends to be more around manufacturing execution, where you can drive productivity and quality all from one use case. But you've got to pick out that first use case, first one or two, let's say, that really take advantage of that reference architecture. So the takeaways from this really are, it's around aligning your organization to the transformation. You're not going to be able to transform to Industry 4.0 or on the roadmap to Industry 4.0 with that very structured, middle management heavy decision-making process that you see today. The speed that data and information moves just will not allow you the time for those middle managers to take in that information, repurpose it, apply their bias to it, put it in a report, send it up where a group of analysts are taking all those reports and putting it together for another report, and so on and so on. That is really not the way you're going to be able to move forward in Industry 4.0. The thing that's going to drive a lot of this is CIOs are just under an immense amount of pressure to support innovation. So you're going to find a willing partner on the IT side to help you build this type of decision-making framework, because they know they're under the gun as well to use all that data that's being generated in operations. And I think, the other piece that's really going to drive this, and why you need this digital engineering group, is operations have typically struggled with maintaining technological discipline. Every plant manager will say they're going to follow what IT tells them until it doesn't benefit them anymore. Then they're going to do it their own way. And this allows you to have the freedom to innovate, but also to maintain some discipline around how you innovate. And I think the reason you have to be looking at these, as it says here, that we've got tangible and measurable positive impact from moving down this digital path to Industry 4.0. And you need this new organization. You have to manage all that new digital technology that's coming in. I'm going to give you another real world example. I think it's really important. We have one of our clients, a very large beverage manufacturer, producer, I should say, that when they go out and they acquire new capital equipment, there is now a small section in the appropriation about not only what data will it need to operate, but what data is it going to generate. So I bring in, and one of the reasons they did this is an interesting story, is they put in a new canning line, and this was maybe 7 or 8 years ago, and it was not really connected to anything. A couple of local things. It was connected to an HMI system to monitor it. And there was a young engineer who was getting called in every weekend and was getting really annoyed at being called in every weekend. And just to come in to look at simple stuff like, this drive or this date or this vision system isn't working quite right. So can you just take a look at it and adjust it? So that young engineer was working with on the PLC, realized that PLC has an Ethernet port on it and it's not being used. So put a work order in, had an Ethernet cable put in, tied it in, bought his own little AWS system. I think they were using Kepware to do the protocol translation, and would sit at home when he got a call. He'd sit at home on the weekend and just look it up, be able to monitor it, had his own little HMI system there to monitor it, make some changes if he needed, or he'd tell someone on maintenance, make those changes for me. And what ended up happening is security noticed on the weekends, there was a fairly large data feed coming out of that system. They didn't know where it was going. They didn't know who was accessing it. It took them a couple weeks to figure it out. And they finally realized this guy had gone around all the security protocols to do this. And so they were, basically he was working with an open port that would anyone could have eventually tapped into. But instead of chastising that engineer, they actually recognized him. They got an award for it for innovation. And I think to me, that's a complete change of what would have happened maybe 20 years ago. That engine, now that's a standard part of every appropriation for a canning line, is what data is it going to be generating and how can we access it? So I think that's something you need to keep in mind as this company that I just talked about is building this digital engineering organization specifically for this purpose. And I think that, they're building it on a reference architecture. I think having that, even a high level reference architecture and who's responsible for which pieces is really important. And just keep in mind that the ultimate goal here is faster and more effective decision-making. It's not to replace continuous improvement. It's not to have direct impacts on the operation itself, but it's really about faster, more effective decision-making that will have an impact that is much greater than any small local changes that can be made. So with that, Kevin, I'll turn it back over to you.
Well, thanks, Kevin. That was a presentation that was really chock full of a lot of important ideas, and I've got a lot of questions for you. To start off, I'm not sure if I should congratulate the middle management layer or send them my condolences. I mean, I know over the last 30 years or so, one of the biggest changes to manufacturing organizations has been shaving away of a lot of those middle managers. And I understand how digitalization or digitization can help with making that possible, but at the same time, does it lead to a more collaborative and slower decision-making process as opposed to a command and control chain of command?
No, I think what happens is it does collapse the organization. I mean, you'll never eliminate all middle management. You've got to have people, generally speaking, at least probably during our lifetimes, actually supervising and providing guidance to people who are actually doing stuff on the plant floors. But what it'll do is, I mean, I see this as much as we eliminate middle managers, we create new levels of middle management. I mean, let's take great examples, ERP systems. 10 years ago, it looked like ERP systems were going to come in and be this command and control center. And instead, it just moved the middle management layer from one spot to another and made them much more ERP centric. I think what we're talking about here is collapsing the middle management layer from 8 layers between a lathe operator and the CEO to maybe 4 layers. And maybe eventually you get down to 2 layers. There's just 1 or 2 in between, but there's always going to be someone in between there that has to have. And I think the key thing here, though, is it's not just eliminating middle management, it's eliminating the personal bias and speeding up the process of decision making. Even if you left middle management in place as it is today, doing that will be a massive benefit to a manufacturing company. And by the way, I wrote a report on this a little over a year ago, and my title of my report was "The Death of Middle Management." When my boss reviewed it, he said, "Look, why don't you change the name? Because you should remember, not only are you and I middle managers, but all our clients are middle managers too." So we changed it to the transformation of middle management.
Well, I'm glad you took into consideration your supervisor's suggestion for all of our sakes. Now, when it comes to IT-OT convergence, is it safe to think about OT as being all about the real-time management and control systems and IT being about the enterprise transactional systems?
I think it's a good starting point. We have one client, a very large heavy equipment manufacturer, that they call it hot and cold. There's on the OT side is the hot analytics that have to happen, and that's real-time process optimization. It can go from really real time where there's automated optimization going on, like some automatically calculated statistical analysis in a PLC, all the way up to you got process engineers who spend their whole day just looking at data coming in and trying to optimize the process and improve the product quality. But that's hot analytics. The cold analytics is taking all that information, the transactional information on the business side and the IT side, bringing that together and making longer term big decisions. Things like, does it cost me more to make something in this plant versus that plant? Or what are the implications to the quality of the product? That's a cold analysis. It's long term. That's more IT centric. Whereas the hot analysis might be, how do I reduce my costs immediately on this machine here by increasing the takt time of the entire process? That's a hot analytics. And that's the OT centric piece. So that's a long answer for your short question of, yes, it's more real-time physical on the operations side, longer term, a little more transactional on the IT side.
Right. So over time, how expert or acquainted with or just conversant with analytical systems our middle managers and subject matter experts will have to be?
I think it's funny you ask that question, because what I've always said is the best middle managers and the ones who move up the quickest in companies are the ones that figure out the information systems. They figure out where the information is and how to access it and apply their skills and knowledge to it. So to get to the real question, I think there has to be some development of skills, but I don't think it's just the development of skills. There are a couple products out there that do what I think needs to get done. And that is, you don't want to hire more. I actually, this is a quote, almost a paraphrase of a quote from a CIO I work with. We don't want to hire more data scientists. What we want to do is make more of our engineers look like data scientists. So I think the focus has to shift from, I want to make my people more analytical and data centric, to I want to give them the tools that let them be more analytical and data centric. And I think, yeah, the more they understand about the data, I think the better off you are. But you're not going to be able to go out and hire, 100 data scientists, and you're definitely not going to be able to hire 100, process engineers that are able to do a full, data scientist job. So you got to find the right tools that move your subject matter experts to look like data scientists, and let the data scientists focus on the really heavy duty stuff.
Good. And it's interesting. Yesterday, I learned how to play classic solitaire on the computer, and I didn't do it by reading the rules. I did it by starting a game and letting the computer tell me when I made a mistake. That's the kind of paradigm we're talking about here more and more, isn't it?
Oh, definitely. I think, there's two aspects to it. There's the aspect of the decision support tool that is giving you scenarios that lets you do some scenario building. So let's say, let's look at today's supply chain issues we're having. Today it's very manual to try to get around that. Someone's got to make a decision. Instead of waiting for a container in the port of Los Angeles or Long Beach, you say, how much, what happens if I fly it from Vietnam instead of by ship? How much is it going to impact my cost? Am I missing a market opportunity? There's all kinds of variables involved in that. Today, it's very manual. It's a little bit better because, we've got supply chain planning systems in place that, provide some support. What I expect to see in the future is, as a supply chain executive, I'm going to say to this decision support system, give me 3 scenarios of what's going to happen, predict what you think the market's going to look like, predict what my cost position is going to look like, and predict what my supply chain position is going to look like if I do this, this, and this. And sit back, you wait 5 minutes and get an answer. I think that is more the type of decision-making support system. Now, there is another aspect that's much more active that I think is probably further out, and that is, as there's an AI monitoring or a bot monitoring the supply chain situation, and immediately starts making some short-term decisions based on the parameters it was given, through the last sales and operations planning meeting. I think that one's further out, where it's much more independent and autonomous, but this decision support system up front is well within reach of us today.
Good. Well, thanks for that segue to the supply chain management crisis. It's really been one thing after another, the immediate impact of the pandemic, the post-pandemic period, and now really the wringing out of the supply chain. What else do you think is interesting about the supply chain crisis? Do you think it's going to end anytime soon?
Well, let me before I start, I like to tell stories. So I'm going to tell you another story, and then we'll draw it out to the final conclusion. I was visiting a client, a large manufacturing company, very large plant. I was in with the plant manager and some of his engineers, and they were, the first thing that was pointed out is this is a 1,500 person plant, and we only have 1,300 people in it because we can't get the other 200 people to come to work. So that's the first. And so then they showed me the result, and that is 6-month backlog of partially assembled equipment. And so, that's kind of where they are. But I think it laid the groundwork for when I took the plant tour was every workstation we went to, they talked about automation. They said, because of cost, because of availability, risk, we're going to automate absolutely everything we can. The bar for automation has gone from, here to here. And they now recognize that with all the data they're collecting, it actually lays the foundation for more automation than they ever thought they could do. And they're just now starting to get all their data organized, data governance models. So the short of it is, take this problem that this company's having, and move it down the supply chain. This is what another reason they had all that 6-month backlog. Their suppliers are having exactly the same issue. So I do think that this is probably short term. And when I say short term, less than a year, but I think you're probably talking on the scale of, 6 to 12 months before we start to see this get rectified, because every supplier is having this problem, and it is slowly starting to get fixed at the very bottom of the value chain. And it's going to have to work its way up to the top of the value chain. And it's going to work its way out through two different factors. People will start coming back to work, and it'll get a little easier. And the automation that's happening is already having an effect. So that 1,500 person plant still waiting on 200 people to show up may only ever take 100 back. So I think, that's something we need to keep in mind as well. But the short of it is 6 to 12 months, I think, of this pain we're going to continue feeling.
Well, that's interesting. It's almost like a circular motion. We've got this skills gap, and that's one of the things that's driving the rise of remote operations centers. Yep. Not so many years ago, we were talking about how plant engineering departments were getting stripped away. But now the focus is entirely different. There's no engineers to employ at those places. So now the automation fix is much more palatable and much more necessary. And the whole attitude towards automation begins to change a bit.
Yeah, it definitely does. In fact, one of our clients said very specifically, they're doing this because the CEO of the company walked around a couple different plants and was amazed at how many salaried people were standing around watching stuff happen. And his first comment to that plant manager is, why do you have so many engineers and managers standing around? And he said, because, if something happens, someone needs to be there to make a decision. So that started this company down the path of putting vision systems in, moving engineers into central locations, this is pre-pandemic, into central locations to better utilize their skills. I mean, basically the mandate was pull as many salaried people out of those plants as you can. And they didn't worry about consolidation of jobs. They just wanted to get them out. They're worrying about that later. Once that's done, they'll start to say, okay, well, now we don't need 100 engineers, we need 80. But I think, that what you just talked about of being able to spread their skills across multiple plants is a huge, huge benefit.
And that leads naturally into a discussion of services and how technology is going to be delivered in the future and how applications are going to be delivered. Could you talk a little bit about the implications of the rise of services and new ways of pricing and using applications?
Oh, sure. I think it's probably one of the fundamental changes to how technology is being delivered now. And so we talked about this digital engineering organization, and I mentioned it a few times, but let's just focus on it. Your digital engineering organization in your company may only be 50% staffed by organic people from your company. The other 50% will probably be, people who are managing the infrastructure. So let's say because this is a heavy data lift. So you need someone in there who's going to make sure the data is always clean, it's always contextualized for your SMEs and your IT people to work with. So you're probably going to pay someone a monthly fee to make sure all the data is collected properly, that the data is stored properly, it's secure, and that the infrastructure around it is maintained. And I think that's going to be a key part of it. You may not own that infrastructure anymore. You may be paying either a monthly fee, or you pay per, everyone talks about wanting to pay, either. One of the things we see a lot of that ties into what you're saying, Kevin, is we see a lot of companies talking about outcome-based contracts. So let's say you buy an asset management system, but you don't pay them the money for the asset management system. What you pay them for is your reduction in downtime. And we see a lot of people talking about that. We have found very few instances where it's happened and people have been happy with it, because you get a lot of lawyers involved in that. But the next step down is that managed service piece, where I don't buy the software, I don't buy the hardware it runs on, and I don't maintain it anymore. I pay a company, maybe some SI or consulting company, I pay them $5,000 a month to get all my data organized for me. And I don't care how they do it. They can bring in whatever application, whatever hardware they want. We've done some studies on this, and that particular part of the market, that managed services for operational data streaming, is probably got a 15 to 20% CAGR over the next 5 years. So it's going to grow pretty fast.
Good. Another player in the environment that we haven't mentioned is OEMs. And I think they're in an odd spot, because even if you go back a year ago, I remember being down in Houston and having a compressor maker say to me, well, it's not trivial adding a device to these compressors to allow IIoT, because even a price rise of $300 to $400 for some of our customers is going to be difficult for us, because we have to compete on that level.
So there's two aspects to that. Again, everything's a multiple aspect for me, but one of them is we do see OEMs, biting the bullet, and they're trying to hide as much of the cost as they can by providing a service in other words, they're not going to charge you an extra $300 for the sensor. What they're going to do is charge you $200 a month to be able to monitor and maintain that drive for you, and to tell you how to use it better. So that's one part of it. The second part of it is that there is no matter how many new sensors we install, there is a massive market of legacy sensors and assets out there that 10 years ago, you really just couldn't connect to the cloud. But now there's, the cost of like simple A to D converters, cheap sensors, the ubiquitousness of connectivity means, I always tell the story, back when I was a plant manager, we had a 110-year-old press. And in 1997, when I looked at what it was going to cost to just capture 3 sensors from that press that were already installed, it was going to be over $50,000. So I said, okay, well, I don't need the data that much. I can pay a person to stand there and write it down. Today, it costs about $1,400 to do the same thing. So there's this ubiquitousness of connectivity and being able to connect that analog signal to the digital backbone that I think is going to drive and continue to drive the OEM's capability to look at their equipment without having to upcharge on a specific piece of hardware to the customer. If they can work the services into it, then I'm not going to say it's a win for both sides, but it reduces the pain significantly enough that it's doable for most companies now. Good.
Now, you talked about predictive maintenance as being one of the best ways to justify these kinds of digital engineering investments. And that's an interesting market, because so many people are coming at it from different directions. There's the OEMs themselves, there's the software providers. I saw the other week where some of the bearing providers are providing their own systems for monitoring bearings, which are, of course, one of the biggest wear out tech pieces of hardware that exist. How do you see that market shaping up? Who do you think is going to end up being the key player there?
I think at least for the next few years, most of it's going to end up flowing through what we call the hyperscalers, and that's AWS, Microsoft Azure, Google Cloud Platform, or GCP. Mainly because it's not because you're going to use them directly. All three of them have built or are building ecosystems around all of this stuff. So all the major players in predictive maintenance, their data flows through those three hyperscalers, and those hyperscalers realize it. So if you really want to figure out how you're going to do this, I would approach the AWS or Azures or Googles of the world and ask them to help you figure this out, because they will point you to a partner. I think that is probably going to be a fit. They'll probably point to a couple partners, but I think, in the end, that data is going to flow through those three companies, and using them as the starting point, if you haven't done anything yet, is probably a key part of this. Good. Now, if I was going to take one takeaway from your presentation as we're coming to a close here, it seems to me that it's that, the decision-making process is more important than any given technology per se. Do you think that's fair? I think that's more than fair. I think it's the piece that most people miss. Good. Now, a couple of quick questions to end. What are the implications of the way control systems are migrating? Is the PLC and DCS going to be around for a while still, or with virtualization and all of these other modes of control systems, are those terms and those technologies going to go away? No, they're not going to go away. I think you're going to continue to see a transformation of them, though. It's just like, if you go back 20 years ago, maybe a little further back now, but you wouldn't recognize the PLC and what you're capable of doing with it today. The PLC went from being a very structured transformation of an electrician's job to now being a full computer. It's the ultimate edge device, is the way I look at it. And I think the industrial automation companies miss an opportunity to market it that way now. They can market it as, the electrician's friend and the ultimate edge device simultaneously. There's not many others pieces of hardware you can do that with. But at the same time, when I look at edge devices that are built to be, mini data centers or connections to data centers on the industrial side, so something like an HPE edge line, one of those type devices, that's, you could probably pretty quickly build a PLC out of that. I don't think they quite go through the rigor of what a PLC has to go through from a safety perspective, but they're darn close. They've got analog, they've got digital, they've got just about any type of physical industrial protocol you can imagine on it. In some ways, if you were smart enough or knowledgeable enough, you could make one of those edge devices do a lot more than what a PLC could do today. But PLCs and distributed control systems and such are still moving towards that digital realm very quickly. I just don't think we see it as much as we do with the edge stuff, the edge devices coming down the other way. Good. Final question for today, Kevin, and thanks much. How does digitization strategy differ for small to mid-sized enterprises as opposed to the largest corporations? What would you recommend to those smaller outfits? I think the smaller ones, there's probably going to be a lot of do-it-yourself up front. But again, I think more so than the big companies, go to those cloud providers and see what they're doing, ask them what they're doing, and they'll point you in the right direction. I think also for small companies, I think, go to your industrial automation vendors' channels. Those channel companies tend to be much more sophisticated than you think. I would go to one of those two and start playing around with it. I think that the key thing for most small to medium-sized companies is you're probably not going to be able to hire the people that you want to maintain it. There's going to be a lot of services involved. Good. Well, thanks again, Kevin. And now that we're just about done, we would like to hear how we did. The exit survey will pop up on your screen as soon as the session ends. Please take a moment to complete it, because we use this information to improve our training sessions. And once again, on behalf of CFE Media, Kevin Parker and Kevin Prouty,
We wish you a very good day, and we'll see you next time.